was like,
Sit like a.
You should go into cinematography.
Sit like a bum.
oh, it's my favorite
Great
book
practice.
series.
You can put it on your resume.
Like,
Yeah,
I will
right.
break that as the
Videotape
School cinematographer.
Be like, I was the school camera.
Stretch the truth.
Oh, okay.
Of course.
Okay.
You got some.
Okay. It's really hot in here.
Yeah,
It
It's
is.
like a temperature change from like out there to in here.
well, it's supposed to get up to 80 today.
How's the temperature in here?
It's hot.
Really hot.
Turn the air down some more. Let me know how. I think that it's all controlled out here behind the desk. So keep me posted as to how it is.
Okay.
Okay.
Thank you.
All right.
She's doing a big fan. That's not
Just
loud.
like ginormous, like one of those fans that are like the models using their like hairs, like flushing the wind.
I feel the same thing.
That'd be so funny.
Like, cause I like mess with them, so like.
That'd be like
so they're
screaming
like-
over
I
the
know
fan
it's
is off.
like not exactly.
And I'm trying to do it without looking, so I don't know.
Yeah, mine are a
So
little
I
big.
go like this
So like,
and
I like play with it, like right here. It's really good.
Ladies, have you done these?
I have studied
Like,
say about them.
For the one with the straight line, do you just want constant velocity or do you want more information?
There's one other thing you could say about it.
The slope? Like negative or positive?
Can Lauren see the board?
Yeah.
Here's my head.
Ready? Okay, so what did you say about the first one? Sorry?
Speeding up with a positive acceleration.
Okay, so it is speeding up. Okay, and the acceleration is positive. What about the velocity? Also positive. Good. Anything else we could say about that? Okay, good. What about the second one? Olivia?
Constant velocity with a negative acceleration.
The velocity is what's negative.
Okay. Oh, because it's not accelerating.
There would be no acceleration because it's constant velocity. It's only accelerating if it's a curved. Okay, good. What about the third one? What?
Isn't it speeding up? Or is it?
Yes.
Yeah, it's speeding up.
It is speeding up.
Velocity is negative. And
Good.
its acceleration is negative.
Very good. It's speeding up. Its velocity is negative. And its acceleration will also be negative because acceleration is always in the direction of the velocity. If it's speeding up, it's in the same direction. Okay, and the last one. Renee, what?
It slows down,
It slows down.
has a positive velocity, but a negative acceleration.
Very good. Okay, so you guys feel pretty good about those then? Alright, then I'm gonna confuse you, now we're gonna talk about velocity time graphs. It's not my goal to confuse you, but I have a feeling it might. So if you guys would get out your notes, there is quite a bit for you to write down, and then we'll talk about it. Okay, so instead of in a position time graph where the time is along the x-axis and the position is along the y-axis, the time is still on the x-axis, but in this case, the y-axis is representing the velocity. Okay, so that kind of changes everything as far as what the slope is representing and all of that. So, where do you think about that? Where were you?
Probably the very last change in direction.
Okay. So, today we're just gonna talk about the shape of them, sort of like we talked about the shape of those. And again, you guys are good at finding the slopes, but just determining what the slope is representing depending on which graph it is that you have. So we're gonna have to start paying attention because they're going to look very similar. So you're gonna have to see if it's the y-axis is labeled for the position or if the y-axis is labeled for the velocity. And that's like the question that you had on one of your assignments recently where like the first table, when you were asked to find the acceleration, first table had a 0 acceleration because it was giving you time and position, but the others were giving you time and velocity, so that's like the difference between those only in graph form. Okay, so again, it's another commonly used plot. In this case, the line is representing the change in the velocity with respect to time. And the slope then at any given point would be the instantaneous acceleration, and the slope between any 2 points would be the average acceleration between the points. So whereas in these, the slope is representing what? What was the slope representing in the position time graphs?
Speed.
The speed or the, in other words, the velocity, right? In the velocity time graphs, the slope is gonna be representing the acceleration, okay? So if it has a constant velocity, that's going to be a horizontal line. As opposed to a position time graph, what did a horizontal line mean with a position time graph?
Stationary.
At rest, right? It's not moving. If the position is staying the same, that means it's not moving. If the velocity is staying the same, that means it's not what? It's still moving, it's not speeding up or slowing down, which means it's not accelerating, right, okay? If it has a sloped line, the velocity is changing. Okay, so if it has a positive slope, that would mean it has a positive acceleration. If it has a negative slope, then it has a negative acceleration. And here's a difference where they will look slightly different. We do need to have the negative values for velocity time graphs versus position is always positive, but velocity could either be positive or negative. So if the line is above the x-axis or it has positive y values, then the velocity is positive. If it's below the x-axis, then it has negative y values and the velocity is negative. If it crosses over and it's partially below the x-axis and partially above, it has some negative y values and some positive y values, that would indicate that it changed direction because the velocity, the sign of the velocity changed. Okay? So we're going to draw some pictures as examples of what these look like. So again, we do need to have positive and negative y values. This is still time along the x, but this is now velocity along the y-axis. So if it has a positive constant velocity with, in other words, 0 acceleration, would I need to tell you that there's 0 acceleration? No, because you should know because why?
Constant.
because it's a constant velocity, right? So that's not really needed. It's understood that if the velocity is constant, then the acceleration would be zero. What would the graph of that look like? The velocity time graph.
Horizontal line?
A horizontal line, good. Should it be above the x-axis or below, or the t-axis? Above, because it's positive. So it's going to be a horizontal line above the x-axis. So if you don't have any negative values, you wouldn't necessarily have to include the negative in your graph, but it's possible that you would have. Okay, so positive changing velocity with a positive acceleration. What would that look like? Good. Because the acceleration is positive, the slope will be positive. Since the velocity is positive, that tells me where I need to draw it, and I need to draw it where?
Top one.
Above the t, right? So that's what this first positive tells me I need to draw it above the t-axis or the x-axis. And this positive tells me that the slope of the line is positive.
Are they always like straight lines? They're never curved, like the position?
That's a good question. I think the majority of the ones we're going to be doing are straight. I can't think of an example where, well, if the acceleration is changing, it could be curved.
Okay.
Any line with a positive velocity will be above the x-axis. So this would have a positive velocity. This would also have a positive velocity. As long as they're above the x-axis, they have a positive velocity. Or it could be a horizontal line that would still have a positive. All of those have positive velocities. Negative velocities would be located there.
Below the x-axis.
Below. So any line that's below, it doesn't matter if it's sloping down or up, or if it's a horizontal line, those all have negative velocities. Okay, lines that are speeding up, what do they look like? This is a tricky one. If it's speeding up, what do we know about? Okay. If the velocity is positive and it's speeding up, we'll call that, what do we know about its acceleration?
Positive.
If the velocity is negative and it's speeding up, what do we know about its acceleration?
Negative.
What?
Negative.
It's negative. So therefore, if a line is speeding up, it either has to be above the x-axis, which means it has a positive velocity with a positive acceleration, so a positive slope, or what would be the other type of line?
Bottom.
If it has a negative velocity, then it will have a negative acceleration. What would that look like? Because it's negative velocity, so it's below the x-axis, and it's speeding up, which means the acceleration is the same sign as the velocity. So if the acceleration is negative, it will have a negative slope. So in other words, they're moving farther and farther away from the zero. Okay, so if it's speeding up, your line will be going away from the x-axis, or the zero value, the zero velocity. If it's slowing down, so again, we have two scenarios. We have either that the velocity is positive and it's slowing down, so the acceleration would be what? Negative, because when it's slowing down, the acceleration is always in the opposite direction. What would that line look like? Yes, it would be in the positive, so it's above the x-axis, and it would be sloping down. The other situation we would have is if it has a negative velocity and it's slowing down, then what do we know about its acceleration? It would be positive, so that would look like this. So if they're slowing down, they're getting closer and closer to the zero, versus if they're speeding up, they're getting farther away from the zero. Okay, and we're gonna talk about more about this tomorrow. If you guys would please read online, I'll post the link if you would like, lesson 4, and there's 5 sections of lesson 4. This is in the first section. They're labeled B, C, and D, the 3 middle sections, and we will discuss them tomorrow. They're all about the slope of the velocity time graphs.
Is it physicsclassroom.com?
Yeah, and I'll put the link for that exact section on Edmodo if you guys want to go directly to it. But yes, it's physicsclassroom.com, and then we're in the one-dimensional kinematics still, and then it's lesson 4, and then it's B, C, and D.
I got the Edmodo app for my phone. Oh, I get like notifications.
I have it. Did you download like the new?
I updated my iOS
Yeah.
7, it's so awesome.
Is
Oh, I
it?
hate it.
I haven't done it yet.
You haven't done it yet?
I was waiting to
It's,
see.
do you want like, it like basically if you have like 3 apps in like one thing, if you click that, it'll like zoom in and then you can like click which one you want. It's really cool. I
Like
mean,
your folder
yeah,
or whatever?
yeah. And you,
I
like,
hate it so much.
you don't like it?
No.
I think it's very
It's very flat. I like it when it's bubbly.
it's yeah, it's a
Wait,
little
what do you
bit
mean?
it
Like
reminds me of like a
Windows.
Galaxy phone.
It
or,
reminds
a
me of like the
Windows
Windows
phone.
phones.
Yeah.
Oh, it doesn't look as like.
It doesn't
I
look
like
as
dimensional
iPhone,
X,
it's
Y,
like
Z.
it